Okay, I come back with 3.4 because last time my internet connection was, connect. So let's come back with example 3.19. Okay, so we invest $1,200 at an annual rate 6%. So if I say invest $1,200, which mean the present amount, which is all the initial amount should be 1,200, right? At an annual rate is 6%. So it's going to be 0.06 for R, right? And next one is a compound semi-annually. So it means what? It means it's going to have two times of compoundings periods per year, right? So M will be equal to 2. That means M equal to 2. The meaning of semi-annually will be 2 times of compounding periods per years. So annually. Yep. And next one, T. 10 years, right? It's a 10 years. So 10 years. Yeah. So that means what? T will be equal to 10, right? 10 years. Yeah. Okay, so we want to find the future amount, right? Future amounts. Okay, so since we have the word compounded semi-annually, we need to use compound compound interest formula. Okay, so we have, I'm gonna use my handwriting here. We have A equal to P times 1 plus R over M raised over MT. Let's substitute, okay? So A is equal to 1,200 times with 1 plus 0.06 divided by M2 raised power 2 times 10, right? Okay, so if you plan to use calculator on this, you need to make sure the power here, either you can simplify it or you have to make it in the parentheses, okay? So I will have, okay, so use calculators. Okay, so I have my own TI calculators here. Yeah. So 1,200 10 big parentheses 1 plus 0.06 divided by 2 close the parentheses. All right. Now raised to power. Again, you can either multiply this power 2 times 10 is 20, or you will have to put out like parentheses here and then 2 times 10. Okay. If you don't do that, right? If you don't do that, you may do like raised to power 2 and then times 10. But that is wrong right away because what you can see now by that by PEMDAS, it's just meaning like it's raised to power 2 only, and then after that multiply by 10. So that is wrong. Okay. I just gonna change it to be 20 because I know that it's raised to 20. And then enter, I will have 2167.33. Yeah. So this is the amount in the future that you may get after 10 years investing 1,200. Okay, so I'm gonna go ahead and move down to the next one. Okay, and in these columns, we want to do some comparisons, right? We have 10,000 in our hand, and we want to invest into like 3 different accounts. Yeah, one account offer 5% interest as simple interest. Okay, and another one offer 5% in compound semi-annually, and the next one is offer 5% compound quarterly. So quarterly mean how many quarter a year do you have? 4 quarters, right? We have 4 quarters in a year. We mean it have 4 times periods compoundings. So let's say quarterly. Quarterly is 4 times in a year. Yeah. So let's we compare it with same T as 10 years. Yeah, so we have 10,000 as starting amount. So that's going to be P, right? So 10,000 for P. 10,000 for the next one. 10,000 for the last one. We have the rate of the first one is 5%, which is the same as the second one. So I'm gonna change all of them to be 0.05 in decimals. Okay, but the first one is simple interest, so we don't have any compounding things. Then we don't have AM. The second one is compound semi-annually, which means 2 times a year. So AM is 2, and M here is 4, because compound quarterly. Okay, T for everyone will be 10 years. So just put out 10 for everyone. Okay, now let's calculate we have simple interest formula is A equal to P times 1 plus R times T, right? So I have 10,000 times with 1 plus 0.05 times with T, which is 10. Okay, so use calculators. You must have let's see what it has. 60 this one 15,000. 15,000. Okay. So keep in mind that simple interest doesn't compound anything, didn't compound anything, all right? Okay, now what about compound semi-annually? Okay, so we have A equal to P times 1 plus R over M raised to power M times T. Okay, maybe I should write this one better, but if you understand the code that I'm writing for CS, you want to learn that, all right? Okay, so let's substitute 10,000 times 1 plus R over N 0.05 divided by compound semi-annually, right? Raised to power parentheses M times T. You can either multiply MT first, is 20, right? But I mean, just put out 20. That's okay to me too. So what is that going to be if you use calculators? You will have 16,386.16 cents. You don't round and round things because that was 4. So this will be, I should have dollar sign here, and because I route to 2 decimal place, I had to have the thing here. Okay. In my that I'm using the formulas 1 plus R M raised for MT for compound interest, right? And the last one, I'm gonna copy this one. Copy up to here. Last one, okay. So 10,000 times 1 plus 0.05 divided by 4, right? Because we have 4 as the n raised to power 40. 4 times t is 40, right? Yeah. So you will have, what is that going to be? So I will have 16,436.19. Okay. Okay. So what does that mean? What does that mean if you compare all up through this case? Right. Which one is the largest? Okay, so this one will give you the highest one, right, highest future amount. So we can note that. So that means what? Note is the more compoundings, the more compound, the better future amount we have, right? So the the more compound, the more time compounds periods in the years. I'm saying the more times compound periods in the years, the better future amount we have for the count, right? So, so that's if I have something like compound yearly, which means one time in one time a year, gonna be less than or when I give you the future amount less than the one have compound semi-annually. And if I have a compound, let's say daily, it must be it must have the amount future amount more than higher than the compound quarterly. And keep in mind that I assume all the initial amount is the same, right? All the p-value is the same, and we are using the same rate, just different is compound, the time periods compound in the years. Okay, so I would like to skip problem exercise 3.18 to let you guys practice with that, and I will give you guys the answer key will be 62,118.98 cents. Okay, and that's gonna be it. Okay, so like I say, if you keep compounded, right? Like say quarterly and then monthly. So monthly is okay. So let's note that m equal to 4 in this case, right? And m equal to for monthly m equal to 12, right? And then daily, what is that? Well, what is the daily? 1 year have 1 year have 306. I just want to make sure because someone say 365. So 1 years. How many days in 1 year? All right, so let's check that. So we have 365 days. Okay, so let me 365, right? Okay, and then hourly, right? How many hours in a year, right? And we're gonna think about that. How many hours in a year? Okay, that's a lot, huh? Okay, let's use this. And on, right? What does that mean? That means if I have m equal to a very big number such as like positive infinity, right? So then indicate that you just compile like many times in a years, right? You will get into a case, and it's called continuous compound interest, right? So we're going to come up with the formulas, and its name as continuous compound interest, and the formula is going to be A equal to P times E raised to RT, and keep my last. These formulas, I mean, if you use the formula for compound interest, unless m become like a infinity number, that's will end up with this form. But you know, just apply, just use this form to make it more convenient. Okay. So in this form, we still have, let's say, A is amount future values. P is principal values. R is yearly interest rate, and it's written in decimal. T is the time in years, right? And last one is gonna be E, and the letter E here I would use is approximately is 2.71828, which actually is a constant number that appear on the calculators. In mathematics, we call it Euler number, but we don't really need to go deeply in what does that mean, but it's just a constant number. And you see in the calculators, if you see the ln here and the green one, sorry, 0, 1 was e raised to x, right? That was the e number. Okay. Another, I mean the e number raised to power x, raised to power x, right? So another button that you can use was this guy, the division here, and the green one of it was, sorry, not green one, 0, 1 of it was e. So if you want to find to use the e number, just click second and click the division here, and you have e, right? Another way you can use, it's going to be second and ln here, you're going to get e raised to power something, right? So either way you're going to get you're going to use that e. Okay, now let's come back with this topics, and we're gonna just use that information to handle example 3.21. Okay, 3.21. So back to the comparison we did before. Now we keep keep using the same amount at 10,000 and for 10 years, right? But with a continuous compound interest rate of 5%. So what will be the totals? So I'm gonna have I don't know, P gonna be 10,000, R gonna be 0.05, T gonna be 10 years. So A equal to P times E raised to power RT, right? So you may multiply R times T first to get the power of E, right? Let's say RT, what is that equal to? 0.05 times 10, right? It's going to be 0.5. 0.5. So sometimes if you don't have RT as a nice number, you have to use calculators with whole parentheses of R and T, right? Okay, so now let's calculate that. We have P is 10,000, and then time with E raised to power, you can put down 0.5, or you can do like 10 times 0.05 again. And then you're gonna have what? Use calculators. I'm gonna use calculator this time to make sure you see that. 10,000 time with E. You can use this E, or you can use this E raised to, right? So use this E because it have raised to R, so use this E 0.5. Okay, enter. You have 16,487.21. 16,487.21 $. Okay. So that's gonna be the continuous compound interest, and that's going to be maximum amount. I mean, maximum amount, future amount, with the highest compound interest offer, right? So compared to the quarterly, you can see it was 16,436, and this one absolutely higher than that, right? So I'm gonna say this is highest amount compared to other compound interest, compound interest. Okay. All right, so I would like to skip 3.20, and we'll let you to do that. Answer key will be 146,189.93. And the next one answer key will be $1,009.26. Okay. So, all right. So sometime we are given the case as finding the present value, but given the future value, like we did in simple interest. Okay. So, for example, how much money do you have to invest in order to have 100,000 in 10 years? So let's say we have A now is future amount is 100,000. right? And in 10 years, I mean, T is 10 years, right? And if we have annual rate is 8%, which is 0.08. And it's a compound continuously. Okay, so compound continuously, I have to highlight that because we're gonna have to use the formula for compound continuously, right? So using compound continuous formulas, or wait, I'm gonna say formulas, right? We have A equal to P times E raised to power RT. Okay, I have to put this into parentheses because I don't want to mess up with that. All right. So the power will be R times T. You can either find RT first, or you can put them in the parentheses. So we have okay, so let's substitute everything. We have 10,000, no, 100,000, 100,000 equal to, okay, maybe I gotta move this a little bit so we can have a coordinate one. P will be, I don't know, time with E raised to power balance R times T 10 0.08 time with 10, right? Okay, simplify it, 10,000, 100,000 equal to P times E raised to power 0.8. All right, 0.8. Okay, so I want to find P. Then I need to divide both sides by, I divide both sides by E raised to power 0.8. Right, I need to divide both sides by that to get rid of P E raised to power 0.8 in the right hand side. So now I want to have P equal to 100,000 divided by E raised to 0.8. And now I can just use calculators and handle that, right? So 100,000, one more, divided by, okay, E raised to power, so click to this one, right? E raised to power 0.8. Go that, right? And okay, so you have 44,932. 44,932. And how many cents? 90 cents, right? Make sure. Okay, the 6 here, route this 9 to be 0 and this 8 to be 9, right? Okay, so summary, to have a future value of 100,000 in 10 years, you must invest 44,932 $90 with continuous compound interest, right? Okay, so I'm also gonna leave this problem for you guys to practice with, and let's say it is answer keys will be 14,816.36. Okay. And also this one, I'm gonna give you the answer key is 30,000, 30,411.17. And keep in mind that we're still looking for how much money do we have to invest, which means we are looking for P, okay? Which means you're looking for P equal to question mark, right? And we are given A was 45,000 there, right? 45,000. T equal to 5 years, okay? All right, what about rate? Okay, R equal to 6%. Weight in decimal going to be 0.06. And is that compound continuously? No, it's compound quarterly. So that means M will be equal to how many quarter in a years? Four quarter in a year. So right. So M equal to 4, right? So apply this is going to be apply compound interest formula, not compound continuous formula, right? Okay, so we will move to the next sections. No, not the next section, but the next part of this session is 3.4.2, which is solving for time. Okay. So this is a you know what, I'm gonna stop video here. I wanna spend 3.4.2 solving for time in another videos. Let me see. Wait a second. Let's see if I can. Yeah. Actually, you know what? I decide to finish this in this video. Okay, so we work together on 3.4.2 solving for time here. Okay. So sometimes we have questions like when we can get the amount future to be something, right? So basically we want to answer the question for when, right? And like I say, in exponential function and log function, whenever you have the question with when, right, for exponential function, you must need to use log, right? Need to use log for finding when. Okay. Okay, so we start with examples 3.23. Okay, so recall invest 200,000. So this is start amount, right? So I will start with P equal to 200,000. Next, he expects the value of the portfolio to increase at the rate of 10% compound continuously. So I'm gonna have rate equal to 10%, which is 0.1. And because this is compound continuously, you wanna have to use the formulas, for compound continuously. all right? And lastly, it's like how long? How long is same meaning at when, right? So how long will it take for the portfolio to be worth 1 million? Okay. So future amount will be 1 million, right? So we have the formulas. A is equal to P times E raised to power RT, right? Okay, so let's substitute. A is 1 million. Let's move this. Equal to P is 200,000 times with E raised to power R is 0.1 times T. Okay. Okay, maybe actually, you know what? Let me move this down. And I'm gonna write like this so you can see this. This was power, so I'm gonna write like this so you can see it. All right. So as you see right now, I'm having 0.1 T is in the exponent, okay? And we need to solve for T, okay? We need to solve for T. We need to solve for T. So T minus S. T right now is exponent, and we need to solve for T. This is exactly an exponential equation, and we need to use log for that. But before doing that, you must isolate the exponential form. You must isolate this guy, right? So let's isolate it first. So how to do it? 1 millions. You have to divide by 200,000. Okay, and you will get E raised to power 0.1 T. Okay. So now you have, let me write it. Okay. So now you're gonna have what? 1 million divided by 200,000. You get 5 in the left. Okay. 5 in the left. And the right, you get E raised by 0.1 T. So what you do now, you will do natural log both sides. Let's say ln 5 equal to ln E raised to power 0.1 T. I'm gonna say take natural log both sides. Right, take natural log both sides. And keep in mind that's if you do logs by 10, that's work too, but I like to use natural log because I see the E there, and that's help, right? And I will move the 0.1 T to the front of it. So I will have ln of E5 equal to 0.1 T. time with ln of E. And I mean, like, ln of E is 1. Everyone should know that, right? This guy is number 1. So you will get what? 0.1 t equal to ln phi, right? Okay. And you will have t equal to ln phi divided by 0.1. So then t will be equal to, use calculators now. ln phi, right? ln phi divided by 0.1. Done. 16, 6, I'm gonna say 16 years, right? So 16 years. So that means what? We have about like 16 years to get to get like 200,000 to be 1 million if I have the portfolio rate as 10% compound continuously. All right, so so that is a case for solving time, right? I would like you to work on 3.23 and compare with my answer. Okay, so go ahead and try in pause my videos and try it in and try to finish this in 5 minutes and then place my and see my answer, right? Okay, so answer can be 11.45 years, and you see here, right? Take the work, please. Exercise 3.24 is a little bit different, but we will still keep using the natural logs to handle that. You can know that in here, say suppose Sam invest 4,000, which means P still is 4,000, and you have rate is 8%, which is 0.08, but it's a compound quarterly. So what that means, M equal to 4, and the future amount is 10,000. So you must use the formulas of compound interest for this one, right? And substitute all this value into it, and phi for the time, for the t, and answer keys is t equal to 11.57 years. Okay. So so I would like to show you 3.26 here. Say suppose you deposit $500 into an account earning 7% annual interest, compound semi-annually. So we are having compound semi-annually. M must equal to 2, right? So notate all things. P equals to $500. Rate is 7%, which is 0.07. M equal to semi-annually 2, right? So what about A? Maybe I move it out here. A A is 1000 only, right? Okay, so we have to use compound interest formula. So we're gonna substitute everything. Say A is equal to P times 1 plus R over M raised to power MT, right? You see that? So you will have 1000 I mean equal to 200 times 1 plus 0.035 here, because I just simplify it. All right, and then what I do next is I divide both sides by 200. So 1000 divided by 200 is gonna be equal to 5, right? And then I do log both sides. Again, you can do natural log or log both sides. That's fine. So take log in this case. I take log in this case because I mean if you don't see the E, you can do. I mean, you can do natural logs or log. It both work, but in the case you see the E, it really recommend with natural log. Okay, so I have log of 5 we go to log of 1.035. So now I'm allowed to move this down. It's gonna be 2t. It's gonna be 5, and that's gonna be log of 5 divided by log of 1.035, we equal to 2t. And I have log of 5, and also divided by 2 times log of 1.035. So use calculators for this case. What is that going to be? So log of 5 divided by, okay, the whole bottoms will must need the penalty because I want to make sure my PEMDAS is correct. So 2 times with log of 1.035. Go that log and go the penalty for the bottom, and I get the answer gonna be 23.39 or 20. I'm gonna say 23.39 years to have future values of 1000 if the present value is 200. All right. So for the last one, I would love to leave it blank for you to practice, and we'll see you in the next class. Okay. All right. That's good enough.